All right, for letter C. So here, you've got an exponential function of 2 to the x minus 1 on the left, 5 to the 2x plus 6 on the right. It would be really, really nice if this was a base of 4. Why would it be really nice if this was a base of 4? Remember, the other strategy, besides taking log of both sides, is to see if you can rewrite the equation with all the same base. Is it possible to rewrite 4 with a base of 2? Yes, because 4 is equal to what? 2 squared. So whenever possible, if you can, rewrite it with the same base. Because then, if my bases are the same, what can you do with the exponents? You can just simply take your exponents and set them equal. So I could just then take x minus 1. Again, power to a power, you would multiply. And then you would solve from there. So it wouldn't be too bad. You just change that 4 into 2 squared. But that's not what we have, unfortunately. You have no choice but to somehow, some way, get the variables out of the exponent. You've got to get them out of the exponent. So the only way you can do that is by using your properties of logs. You can do log base 2 of both sides. You could do log base 5 of both sides. You could do log. It doesn't matter. You can do the log of any base on both sides of the equation, but you got to take the log of both sides. I'm just going to go ahead and do natural log. So natural log of 2 raised to the x minus 1 is equal to the natural log of 5 to the 2x plus 6. Now you can use your power property of logarithms and yank the exponents out. So I have x minus 1 times the natural log of 2 equals 2x plus 6 times the natural log of 5. So remember, natural log of 2 is not a pretty number, but it's a number. Natural log of 5 is a number. It's not a pretty number, but it's a number. So somehow, some way, you're now going to have to get rid of the parentheses, so you're going to have to distribute the natural log on both sides into the parentheses. So x times the natural log of 2 minus the natural log of 2 equals, distribute the natural log of 5. So we have 2x times the natural log of 5 plus 6 times the natural log of 5. Remember what you're solving for. You're solving for x. You've got an x on the left and an x on the right. So you want to bring all the terms that have an x together on one side and move everything else away. So I'm going to move my 2x natural log of 5 over to the left. So x times the natural log of 2 minus 2x natural log of 5 is equal to the natural log of 2 plus 6 natural log of 5. So again, remember, when you've got terms that have more, that you have the variable that you want to solve for, more than one term, you've got to isolate them on one side. Now, what can you factor out on the left? You can factor out a what? X. And then finally, what can you do here? You can do what? Divide. There's a lot of different manipulation you can do with properties of logarithms on this answer. So notice what I can do. Can I condense the numerator through my product property? Yes. So again, there's a lot of different variations of what this answer could look like. I could rewrite this as the natural log of 2 times 5 to the 6th power over the natural log of 2 divided by 5 squared, or 2 over 25. Now we had this discussion last period. This is not equal. This is not equal to just writing the natural log of the whole thing. 2 times 5 to the 6th over 2 over 5 squared. They are not equivalent. You can type in the calculator if you don't believe me. Because remember, this is the natural log of some number. What this is doing is you're finding whatever the natural log of this product is. whatever this number is. Then you're dividing it by the natural log of whatever this number is. So the division is secondary. You're doing the natural log first. Versus if you write this, what you're doing is you're going to take 2 times 5 to the 6, divide it by 2 over 5 squared, and take the natural log of that quotient. So it's a different operation, so be careful, watch that. You cannot really do much more than that. Alright? So you could get a calculator of like 2 times 5 to the 6, and but other than that, there's really not much you can do. Again, but remember, you may see different bases. Because I could have back here, your answer may look a lot different than your friend's, because back here when I did the natural log, somebody may have done the log base 2 on both sides. And your answer is going to look completely different depending upon what base you take. Doesn't mean your answer is wrong. If you're not sure if it's equivalent, take out your calculators and see if your answer, type your answer in the calculator and then type in whatever answer you're comparing it to and see if the decimals the same. But depending upon what base logarithm you took up here, your answers could look vastly different, but they could all be equal. All right? So any questions on that? All right. So ladies and gentlemen, so for tonight, like I said, all you have for homework is the quiz review. So everybody should have a copy of the quiz review. I gave it out at the beginning of class.